So the question of diet has a lot to do with nutrition, right? Vitamins, minerals, we'll go over that later. It also, when we talk about food, it is psychological. Why is that? Why is food intake psychological? Anybody got a guess? That's a good guess. I'm glad you spoke up. It didn't get awkward. What have we been talking about all semester? What is the foundation of our needs and what impacts our motivation? Would be food, water. We are so aware, more so probably with food than anything else, around where it is, when we're going to eat, what we're going to eat, when are we going to shop, how much food do I have? Because food is so vital. You will die without it. You'll die without it. We don't necessarily have the same issues around water because we have access to water, clean water. At least here we do all the time. So there really is no major issues in this country around water obsession, right? So food is one of the foundational psychological evolutionary needs, and it's very easy for us to become preoccupied by food. And so today, before we get into that conversation, because we will transition into food disordered eating disorders as part of the curriculum I have to cover after this conversation. But this will prep you for kind of how this might impact someone in a negative way. But so this is a very brief cellular biological explanation of two main things. Hunger, which is the biological need signal, conscious signal for food, and fat metabolism, which is right with both of those two work very closely together. Those are not separate, okay? This perspective is not, I'm giving you the perspective from rest, right? This is not marathon athletes perspective. We're not talking about someone in the middle of, heavy weight training perspective, talking about general human beings at rest, how this works. So let's start with hunger. So the hormone, there's multiple hormones involved. So I'm simplifying a very complicated situation, but it's not so complicated you guys can't understand it in one lecture, okay? In 1994, they discovered that your fat produces hormones. Prior to that, they did not know fat produces hormones. And those hormones talk with other organs and to some degree regulate the rate that other organs work. So they crosstalk. So this is a very big deal. It was huge, actually, because prior to this, they just assumed it was this resource or gasoline type fuel for the body that could be accessed, that it was like insulation. Fat is also cushion. And they also knew, like, when people become super ultra lean, they might not be able to reproduce. So there was something connecting to body fat and reproduction, as well on the high end of body fat. The more excess body fat you have, that also can affect reproduction and other things like diabetes, like your pancreas, how this all works and how it functions together. So this discovery in 1994 was a big game changer. So in 1997, so 3 years later, it had a name. And the name of this hormone is called leptin. Leptin. How many of you have heard of leptin before? In just a regular class, nutrition class? Okay, so this might be a review for y'all. So leptin, what they first discovered is that if leptin levels are low, and leptin comes from your fat, okay, but it also comes from other areas of the body. But if you do blood leptin, if you do blood leptin tests, the number you're getting is 90+% coming from body fat. So it's an indication of how much is coming from your fat, not so much from your hypothalamus or from the other areas of your body. So so when I say leptin comes from your fat, that's the primary source. That's like, again, most of your leptin that's in your blood, floating through your system, comes from adipocytes, big cells, big fat round cells. The leptin comes from your fat. Okay. So what they discovered is that when leptin levels are low in the brain, these agouti and neuropeptide Y, those are enzymes in the brain that they become super active. Do any of you know what agouti and neuropeptide Y in the brain do in the hypothalamus? Anybody? Okay, you don't need to know this. They make you agitated and hungry. Hangry? Any of you been hangry? That's because those two enzymes are angry. They're active. So leptin levels, when they're low, those two enzymes become very, very conscientiously, your conscious awareness becomes like a little upset, and it's agitating, and there is a time constraint to it. Like it's like this pressure to do something as soon as you can, and it's of course pressurizing you to eat. I'm hungry, I need to eat, I have food, I need, and you'll feel kind of like your head will hurt, right? When they discovered next, when leptin levels rise, there's a certain point at which those enzymes, the agouti and neuropeptide Y, shut down. So your hunger goes away. Now, as leptin levels continue to rise, it doesn't make you full, right? Leptin just makes your hunger, the agitation, go away. What do you think makes you feel full? Simple, not complicated. Anybody have a guess? Yes, she said your stomach. Yeah, the mechanical problems of having too much food in your stomach feels full. So you can have enough leptin, right, to turn off hunger, but if you keep on eating past that point at which hunger is relieved, you're gonna start having other problems like mechanical overfeeding. So leptin, when leptin is elevated, hunger goes down. When leptin is lower to a certain point, right? You could look at this like an upside down U curve. It's like there's a Goldilocks zone here. So this would be hunger. Which one is hunger? Which one is leptin? Oh my God. When leptin levels go up, I think this is leptin. X is, it's been a long time since I've actually done this on a graph. Right, when leptin levels go up, hunger, yeah, if leptin levels are too low, hunger, is that right? What the hell? Don't mind me, I'm supposed to be the smart one in here. But just know, when leptin levels go up, hungers go down. When leptin levels too low, hunger goes up, okay? That's the first thing they discovered. Then they were like, well, this is coming from your fat cells, right? So your fat hormone literally can regulate your hunger rhythms, okay? The next thing they discovered is that what leptin does in the fat cell. Here's a fat cell, an adipocyte. Here's your little mitochondria. What does the mitochondria do? I know you guys know this. I know some of you do. At least a handful have to know it. Powerhouse. Yes. What does that mean to someone who's never heard this before? What does the powerhouse do? Because that's what you'll read in literature, but what does that mean? What does it do? What's the function of the powerhouse?
It creates energy.
Yeah. Yes, it creates fuel. There's a difference. between energy and fuel, okay? It produces fuel for the body. So it takes these macronutrients, right? And it can specifically chop it all up. And then the end result is what's called ATP. So just think of this as our gasoline. Fuel. Okay. So here's a fat cell. This is the fatty acid strand. The acyl group here, triglyceride, right? You have fat all over in there. And in order for this fat to be broken down into fuel, it has to get into this mitochondria, this organelle. If it's not in the mitochondria, it doesn't break down, it doesn't create fuel. It has to be in there, in this, to create ATP. The powerhouse, right? What leptin does, so when leptin levels are elevated, it allows the gate here, so this is a double membrane organelle. You don't need to know that, but there are, think of it like there's pathways, there's doors all over the membrane of the mitochondria. And the called CBT, don't need to do that. I'm just gonna leave it at this. So there's a bunch of doors on the mitochondria. That fatty acid has to get in there. What leptin does is it allows melanoid-CoA to attach to, so this is closed generally. So when there's more leptin, these gates open up. Those gates open, allowing this acyl group to attach onto the membrane. It gets pulled in, can go through beta oxidation, which traps it up, and then spits it out as ATP. So this becomes two inside here, two doubles, blah, 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 cuts it up, ATP. So increased leptin increases fat metabolism because it allows for beta oxidation. So any of you are going to keep on going in physiology or any type of pre-med, any type of physical therapy, any type of chiropractic, you have to know this, and you got to know a lot of details. I'm cutting out a ton of details. From here, it can go through the Krebs cycle, the electron transport chain, and that's where we get the ATP. You don't need to know that, but here's all you need to know. Increased amounts of leptin result in increased fat metabolism. Increased fat's ability to get in here and go through beta oxidation to produce ATP. So ultimately, your fat produces hormones that regulate its own fat metabolism. If you don't have enough, even if you have a ton of body fat, it's not accessible. It doesn't, you can't access it because you might not have enough leptin to allow for these fatty acid strands to get through that door, right? Maybe it's too slow to produce enough fuel to meet the demand. Any question? Okay, anybody have a question you stop me? So when they next found out is that if leptin levels go down, right? Again, we're looking at a range. As leptin levels go down, these shut, right? Which means there's less fat metabolized, which means you have less fuel available from fat. So, rate limiting step right here. This is really important. Any questions? Okay, so we're going to move on. So what are the fuel resources? So this is something you're going to want to know. Anybody know what the 4 fuel resources are for our body? For all the functions? Say it louder. Glucose. Yep. First we have blood glucose. And glucose, well, we'll get into that. Actually, Yeah, what is this primarily regulated for? You know, we all have different body sizes, different amounts of lean muscle, different thyroid function. We really do have differences in terms of how our bodies maintains balance or homeostasis. But there's something very similar about every single one of us, and it's our brain. How much glucose needs to be available for the brain? Your brain truly, really only likes glucose. It can have ketones, but not ideal. That's actually not a good idea. However, it can, and it will, right? Ideally, we have glucose in the blood available for your brain. So what regulates blood glucose ranges, we're all the same. Every single one of us should be in the same exact range. And that's because our brains are identical for the most part. We have the same needs for glucose for the brain. So the amount of glucose in your blood right now is not regulated for your skeletal muscular system. It's not regulated for your liver's needs. It's regulated for what your brain needs. That's important, right? What is another fuel source?
Carbohydrates.
That's what glucose is. Awesome job. Carbohydrates. Carbohydrates could be eaten in complex or simple forms, but they ultimately digest down to glucose. But they can also digest down to these other fuel sources. What's another fuel source? Anybody know what's related to blood glucose? A source of, let's say, carbs in the muscles?
I don't know if you put like protein and like that.
Yes. Well, I'm talking about something different, but you're right. Protein is a fuel source. So your muscles, your body.
Glycogen.
Yes. Woo! Winner. Glycogen. So glycogen is a source of fuel that's basically stored carbohydrate. It's changed slightly and it's stored in your liver and your muscles. And it is a fuel, it's a pool of fuel that is readily available, can be broken down very quickly and produced into glucose quickly. So glycogen is stored fuel that breaks down into glucose very fast. Okay? Liver, and this is typically available when you need high energy right now, right? So typically this is we'll go back to blood glucose, regulated for your brain. This is your brain's food. Glycogen is typically for skeletal muscle. And it's primarily used for, let's say, fight-flight activity. This is a primary source of use. And we talked about fat. So protein can be used, but not ideal. Not ideal because your body does not discriminate where it takes that, where it takes the muscle, right? So it'll take it from your heart muscle. It'll take it from all of your tissues. So it's not an ideal thing for your body to metabolize protein, and it doesn't want to, it doesn't need to, and there's other processes that protein digestion, specifically your body eating its own body for fuel. That's what happens when you're starving. It's hard on your kidneys, right? Your kidneys have to process that protein and end up being really worked. But if you're starving, you're just hoping to stay alive. But protein can be used. It's really not the best resource for, it's like last ditch effort, starvation. Your body will, if it has to, take from your tissues. So fat is really for rest. And rest up into a certain point. So your body primarily at rest is using fat. It's kind of always using all these, like I'm standing around here, like I'm pacing around, I'm using my arms and my muscles. So there might be a little bit of glucose being used, but I would say right now I'm probably using 90% body fat. because I'm not really doing a whole lot. In fact, I'm gonna use quite a bit of body fat until my cardiovascular exercise gets up to around 60% of my VO2 max. You don't need to know that, but this is the primary source of fuel for your body at rest. Blood glucose is really supposed to be preserved for your brain. So a lot of people are like, well, glucose is. No, actually, fat is. And fat gets broken down right here into acetyl-CoA, and it goes right into the Krebs cycle after beta oxidation. It does not have to go through glycolysis first. So those of you who are knowing what I'm talking about, who've already learned all this, it doesn't have to. This is so efficient and effective. Body fat is so effective. Glycolysis, which is the breakdown of blood glucose, is awesome too. In fact, I might be using a little bit of blood glucose, but not really. I'm using that. So if I were to start sprinting, let's say I needed to get down to the Bronco gym, what source of fuel am I using? Probably all of the glycogen I got. It's gonna last, if I'm sprinting, 2 to 3 minutes. If I'm an endurance athlete and I'm trained to run at a very high level for an hour plus, let's say I'm running a marathon for 3 hours, I'm going to use all of my glycogen. I'm going to use all of it. And I'm also going to be using some fat, but you'll be using all of this. If you're weight training, you're probably using these two primarily, right? So you can, it does have flux, and that's what it's called, flux, around what source you use, but at rest, it's fat and it's regulated by this hormone right here. Okay, any questions? What does blood glucose fuel primarily? What is it regulated to fuel? The brain. It can absolutely be used for immediate fuel source, but there comes a point at which the brain gets pissed off about it. So what happens if your blood glucose levels, if you don't have, and this is where you need to pay attention. I'm going to write this in red. So as leptin levels decline, there is a gradual decline in fat fuel. Well, let's say your demand, let's say your need for fuel, we'll use a scale of 10. You need 10, whatever that is, you need 10 of them. And fat's providing quite a bit of that, a huge percent at rest. But let's just say you start to walk downtown, right? You're gonna have to walk back. And your leptin levels, for a lot of different reasons, start to decline, and your fat is only providing a 7. Right? But you need 10. What happens is it'll take the 3, you drop to a 7. So you are -3. Okay, I'm just really simplifying this so you'll understand it. So what will happen is the body will say, okay, well, we can take it from blood sugar. This is so simplified. It'll take it from blood sugar, and then guess who gets pissed off? Your brain. So when blood sugar goes down, what do you think happens to the amount of leptin in your brain? So we know this, that blood sugar regulates brain leptin levels. Right? So your brain leptin levels go down. And what happens when brain leptin goes down? Yeah. Good job. Yeah. So there's a decline in leptin that makes your fat insufficient to fuel your body at rest. Your body will take it from blood glucose. And then your brain registers that there's not enough glucose because leptin levels go down in the brain, which then activates neuropeptide duty, and you get hungry. This is such a big deal. This discovery of leptin was huge in terms of recognizing the connection between your brain's conscious awareness of your fuel availability, when you need to eat, how much you need to eat. So your hunger goes up. So this is why food is really important, because when you think about food, especially food that is delicious, your body already starts to go, oh, sweet, we're gonna have food. And food stimulates your fat to release leptin. All food, every type of food that you put in your mouth stimulates your fat's leptin production. Okay, some food are more powerful to stimulate leptin than others. And food is not the only thing that tells your fat to produce leptin. Stress tells your fat to release leptin. Why do you think that would be? Because if you're stressed and your fat is releasing leptin into the body, then you're primed to use fat. Why is that? Why would that be important? I know it's a tricky question. It really is. You really have to think. What would be the benefit of your body producing leptin, producing more fat metabolism when you're stressed?
So then he uses fat as his, to save the blood glucose and glycogen for like fight or flight.
Yes, that's one. That's the central nervous system. Yes. It also decreases your need for food. You do not need food when your leptin levels are elevated. Your need for food hormonally is regulated by leptin. So if your leptin levels are elevated, your need for food goes down for this purpose. There's other reasons to eat food, but hormonally, if you are not hungry, leptin levels are sufficiently elevated, okay, which means your body is sufficiently being fueled by fat, which means you don't need to eat, which eating will stimulate leptin. So do we have all this together, at least on this side? You good? There were some answers on this for your homework, just so you know. In class. Anybody confused about that or have any questions? So they were like, holy shit, leptin is amazing. It's regulating all these things. And they found out it regulates the thyroid, which is even cooler, right? So your thyroid, if leptin levels go down, and I want you to think of the thyroid like this. This is a light bulb. The simple way to think of it, it's very simple. Okay, simplified it here. Your thyroid is the light bulb of the body. If it's working properly, it's lit, bright. This is the sort, when you feel energy, this is what we're talking about. In combination with some gonadotropins, but in general, your thyroid really regulates your energy. So if you have enough thyroid hormones, you have more energy, you're awake, right? If you don't have enough, it's dim, you're tired, you're just tired, right? So leptin, they discovered in the brain, regulates the thyroid. So if you don't have adequate leptin, not only do you get hungry, but how many of you have gotten really hungry and you're also like, my head hurts and I'm tired and I'm cold? Anybody? Me too. That's the response from your thyroid, which is regulated by leptin. Look it up. It's pretty cool. So if you have adequate leptin, you have a higher metabolism, right? You're more awake. You don't have enough. So when they studied starvation, they studied very specifically if leptin is too low, body fat or fat metabolism is too low, blood glucose, hunger arises. if you do not respond, the thyroid suppresses. Why would that be beneficial in starvation? Why would it be beneficial for your energy to go down?
Then you're not burning.
Love it. Say it so everybody can hear it.
Because then you're not burning as much fuel.
Yep. So it's like a way to create a new a new balance point where your energy is matching the 7. So does that make sense? So if you're at a 7, in terms of the difference, I need a 10 and I'm at about a 7 now. Your blood leptin levels are down, your blood sugar starts to get used, your brain's leptin's going down, you get hungry, you don't respond by eating. There's a point at which the thyroid then starts to slow things down so that your needs, regardless of how much muscle you have, becomes a 7. So it creates a new equilibrium. And that way it can preserve your body for a longer period of time. The human body is capable of not eating food for a long time, like 30 days or more. The more body fat you have, obviously you can live a lot longer without eating, but that's how it does this. It's amazing, evolutionary wise. This is how the body can sustain life without food for long periods of time. And any of you who've actually starved will say, yeah, and you actually feel better once it does this. Kind of cool. I mean, it's not, but you feel better. You feel like you can be fine. I mean, you're kind of at a lower energy. You're not as vivacious. And on top of that, you're also probably getting cortisol out of stress, which also can make you a little more alert. So it can compensate for that. So the thyroid is highly regulated by leptin as well. So they learned all this and they thought, wow, let's look at how this functions with a spectrum of people with different body fats. Because their first thought was that people who have, so if leptin is produced primarily from body fat, and it regulates hunger, and it's regulating fat metabolism, they had their first hypothesis about people who were morbidly obese. What do you think it was? That's what they thought. They thought they must not produce enough leptin. They have all this body fat, but maybe there is leptin resistance. It's not working. It's not working. There's something wrong. Because they think they're must be super hungry all the time, and they're not using any of their body fat. So what they found is that here is 2 people. Let's say it's the same exact person. Hello. Same exact person, okay? This person has this amount of fat, and this person has this amount of fat. Okay. What they found is that this person produces leptin. This person produces a lot more, exponentially, like exponential, which means each cell produces significantly more body fat. The smaller cells of fat don't really produce that much, but the larger the fat cell, the ratio of fatty acid to mitochondria, you can imagine this is going to have more doors, right? And less fat. This has a small mitochondria with less doors for a ton more fat, and it's producing a significant amount more leptin. Okay. So they're like, whoa, 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 hold on. So you're saying that this person is supplying, when leptin is stimulated, this is the important. when leptin is stimulated to be released, we should actually say it this way. When fat is stimulated to produce leptin, let's say this person eats an apple, and this person eats an apple. Same exact macronutrient, right? Same exact macronutrient amount. 80 calories. Same exact. That same exact stimulus gets a very different response. Because this person has maybe larger fat cells producing exponentially higher amounts of leptin, right? Than this person. So this person might actually, if you teach hunger, and then you teach the difference between emotional desire from hunger, which you should, if you're gonna be in any field that talks about food, there's two very different things. Hunger is not the same as desire. Leptin levels can be elevated and you can be, you know, in a state of victimhood. You know, I deserve to eat because of some emotional need, which we will go over in a week. That doesn't mean this person's hungry. They might have eaten half of the apple and hunger was gone, just gone. They didn't need very much. This person, on the other hand, is still friggin' hungry and needs 2 more with some peanut butter. Because they're super friggin' hungry all the time. You guys know anybody like this? I know everybody. When I worked in a medical weight loss clinic, we saw people from here to here and anything in between. And we'd teach them what hunger feels like, which distinguishing of it from mental desire. And we would have them practice. And these people would be like, you're right, I'm freaking hungry. This person would come back and go, I can't believe it. I had one patient practice and hadn't eaten for 2 days and was like, I can't tell you how good I feel right now. Like, I feel freaking good. It was nuts. It was amazing. I was like, well, you might need some salt and maybe some protein. But it was medically supervised. And we were trying to teach kind of like looking at leptin and looking at insulin and their, you know, diabetes and testing all of this kind of like ideas and not hungry. Now, if you were to go look up research on leptin, you're gonna hear a scientist somewhere going, well, they have all this leptin, but because they're over consuming, it must be resistant. As if someone eats because they're starving all the time. How many of you eat when you're bored? Right. How many of you eat to celebrate? So does that mean that this person must eat all the time? No, it means that they're highly sensitive to food because their body produces way more than this person. Any questions about this? It's pretty cool shit. I mean, I love talking about it. So there's more. But wait, there's more. This is super exciting. Let me get back onto my frame of mind. So there are needs for food. So in terms of, I want you guys to think about hibernation, like a bear in hibernation and how they can live for months and months and months without food consumption. Essentially, what they're observing is this person could hibernate. They don't need very much food. And very little food gives them adequate leptin. So if they eat because they're bored, if they eat because, like what this person does, they are highly sensitive. Oh, that's where I was headed. So what they found is extreme amounts of leptin in people with more larger fat cell body fat. So specifically visceral fat, fat in the abdomen, inside the abdomen, which is more white. It has a lot more lipids. It's a lot larger adipose tissue, a lot larger adipocytes. Those are the ones that produce the most leptin. And what they found is when you have high levels of leptin, high levels of leptin, and you combine it with that much fuel availability, too much ATP, that is what stimulates the DNA and cell division to create new fat cells. So when you have excessive amounts of leptin with all the fuel available without it being used, that is what stimulates fat cell division, new fat cells. And this fat cell isn't, I mean, our bodies are incredible at adaptation. So this fat cell gets bigger and produces more. So this is why it is exponential when you compare this person to this person. Exponentially higher amounts of leptin because of the stimulus of the ribosomes and the DNA that produce more fat. So in essence, it's an incredible mechanism that says, well, we must need leptin, one, so the adaptation is we must need more, so let's produce more, and we need more fuel storage, so let's create more fuel storage. So once this happens, and keep in mind, you don't have to eat to stimulate this. You can be stressed. Just stress. And where does stress come from? Probably insecure hierarchies of need. Job loss. Threat to your access to food is one. E.g. dieting. Actually, we know psychologically triggers extreme amounts of stress, which makes someone more sensitive to fat gain. Did you know that of all people dieting, all of them are going to gain more weight? There's like a 2% group, 2% that don't, and they typically have some degree of obsession over not regaining the weight. So dieting is not necessarily advantageous when it psychologically triggers insecurity with food, because your brain, your psyche is primed when there is a famine, whether it's real or not. If you perceive food is going away, you can't have more, there's not enough, it's dangerous to eat, and again, we'll talk about this more in a week, this whole thing, this gets triggered. So someone in fight or flight who looks more like this is primed to hibernate. They don't need to eat. So if something cataclysmic happens, this whole class, we're all gonna die, because no one here has enough fat to live. We don't have anybody who could survive it. This person's gonna survive. They're gonna be hanging out going, I'm not hungry. I don't know why you guys are so angry. Go out and hunt. Go, I will tend to your children. Because they're not hungry. They're not. And they need much less food. And your body has all this stored vitamins and minerals in the fat that can actually increase their vitamin D without needing to eat. They have higher vitamin D levels when they lose the body fat, right? So as people lose body fat, there's all this nutrition that there's being released into the body. It's evolution, how it works to survive. So cool. Any questions? So the problem or the difficulty here is that once you have accumulated large amounts of these larger white adipose tissues, they are very difficult to lose because of the small, tiny little mitochondria and the fact that there is not enough doors. So what they did is they took mice who were obese and they stimulated, they did an external stimulus of leptin that required they didn't eat. So they wouldn't eat. They weren't hungry like you would predict. So they stopped eating and they became more active. And even though they were obese, and then what happened over the course of time is they obviously lost a ton of weight because they didn't eat. And their energy was good because they checked the thyroid, and their thyroids were actually being easily maintained with this exogenous leptin stimulus that wasn't food. And they didn't lose any lean body mass like you would expect, because leptin levels were held at that adequate zone to where they didn't have to tap in to these, to protein or blood sugar. So leptin alone was enough. If you had an external stimulus without it being food to access these. So what they found after the fact is they went in and they did their biopsies, and they wanted to see the pre and post of what happened to those fat cells after this experiment. And what they found was basically a raisin. Obviously, because the lipids all got sucked into that mitochondria and got spit out as ATP, but they found new mitochondria. So when they found an increase of leptin combined with an increase of fuel expenditure, you actually stimulated the mitochondria to multiply. The problem is you can have an increase in leptin, but if you have too much, it's not a good thing. If you have too little, it shuts down everything. So this fat cell, if there's not enough leptin, won't get tapped into at all. It's just not accessible. So this is where when someone loses a lot of weight, they may lose it in their neck, their arms, and their legs. But that visceral fat doesn't go anywhere. It takes years for that to go away. That's why, because those fat cells are so difficult to tap into because they don't have the right size mitochondria. It's not equally as large, right? Very difficult to get into, because someone, if you look at like their needs for, can you guys see this? Let me take this down. I don't need this. Someone's need, think of it like this. So if you were, here is a normal person's need for leptin. This is what I call the Goldilocks zone, right? It's here. Pretty wide, go down, it could be too much. When you get someone who's morbidly obese, it looks like this. Way up here, it comes back down. That's it. They're so quick, and it actually moves this way, like this. Too much on this end. So it takes very little to get to too much. It makes it so difficult to lose weight. So difficult. And if you don't tap into these fat cells, you're going to gain it back because you're still producing too much leptin relative to your expenditure. Which means that when you look at the diet industry, they're really setting people up for failure there. They all suck, in my opinion. Even at the clinic we were at, it was really hard. Even if we could give them this information, when you take a human being, I don't care if it's this human being or this human being, and you say, you cannot eat with your family because you're not hungry. You can't go on a date and enjoy a glass of wine because that's going to tip you off the edge. How does that sound? Kind of shitty, right? Deprivation. It's called relative deprivation. Psychologically, you're saying you have to be disconnected from your belonging. And what happens when you take and you restrict food because they need to, it's going to have an unintended psychological consequence because we're not mice. We have way more processing, way more intelligence, way more psychological need to make sure that we can foresee that we have food in our future. So someone who chronically restricts has to isolate from reality. They cannot be in public. It's too hard. They have to remove all temptation. because they're inflamed already because their first hierarchy of need is stressed out, right? So it puts this person in a very awkward position, but yet this person here is like, hi, I'm your trainer. Let's put you on a diet, right? This person's like, you should be eating so and so calories. So this person's actually burning probably around 4,000 to 5,000 calories a day. When I did metabolic testing for literally hundreds and hundreds of people, this person's probably only burning 1,700 a day at rest. This person's burning at least 4,000, 3,000 to 4,000 at rest. Right? Your liver alone is 25% of your fuel needs. Your brain is 25% of your fuel needs. 50% of your fuel needs in a day is just to feed organs or plus more. Your lean, your body, your muscles are not as demanding as we'd like to think. And actually doing physical activity doesn't really compensate a whole lot. This person, when they exercise, is getting way more out of it. So it would help to exercise because they can use the fuel expenditure, but they still have to maintain this range of leptin, which means that it's very difficult psychologically. Any questions? So one of the assignments that you are going to be given, I'm not going to give it to you today, I'll probably give it to you on Wednesday, is to track your hunger for over a week. So you are to observe when you actually get hungry. So we need to talk about the difference between mental desire, the need, the triggers of what would create impulsivity to eat that have to do with a threatened first hierarchy of need. Those are not the same as true hunger. Okay? That makes sense. There is a biological rhythm that would be relative to leptin. That's what I call biological rhythms of hunger, which is very different than habit, than because I'm supposed to. It's very different than for some of you who are athletes. There is timing and need to time your food consumption post weight training. There are real things there, but would you recommend that for this person? Hell no, don't do it. Not the same. So what you would tell an athlete is super inappropriate for the same athlete with this much body fat. It's not good for them, right? So you would need to adapt to the person and recognize, hey, first and foremost, if you are not hungry, there's the zone, you have 2 hours-ish. You can do it within 30 minutes, awesome, maybe you'll be hungry. But in general, this person can handle that. Yes, if you are this person, post weight training, you need 20 to 30 grams of amino acids after you weight train. I know I haven't taught you any of this yet, but we'll get there. But I wanted you to know the difference while we're in this conversation. That this person should not be doing what's his face podcast who looks like this person is telling you to do. We had so many people come to the clinic who were motivated, like they really were wanting to make changes in their lives. And they were listening to podcasts from people that look like this about what they should do, which would be appropriate for someone like this, right? And they'd be like, okay, well, I'm weight training. And I'd be like, yes, this is amazing. And I'm waking up and I'm going for a walk. That's amazing too. I'm getting good sleep. Should I be supplementing before and after I train? And I'd be like, slow down. No, not yet. Not yet. Because this is more important so that we can tap into the tiny little mitochondria and at least give it enough time to actually adapt. This is not easy. Okay, any questions before I erase all this? So we're going to get into hunger. How to differentiate real hunger with our last 15 minutes. Did you guys follow along with that? This is recorded. I have last semester's recorded as well and posted. So you can always go back and listen to it. And again, these are I approach this from the perspective of at rest, right? If you were a marathoner, that changes. Like leptin doesn't really get stimulated until someone is like in their last bits of exhaustion. So exercise for different people can stimulate leptin because of the stress, the central nervous system response, sympathetic nervous system. But because of how much body fat, it depends, right? Like someone who's lean that runs a marathon, not gonna have the same response to someone who's morbidly obese, might have 50% body fat. When are they gonna stimulate? When does exercise stimulate their leptin response? Gonna be different, right? That's the hardest part about the research with leptin is the fact that it's such a moving target, depending on how much body fat a person has and the type of body fat. Is it visceral? Is it that big white visceral adipocyte that is going to explode leptin? Okay, so hunger. So hunger, I mean, how many of you heard of the hunger scale? Anybody heard about the hunger scale in here? How about intuitive eating? So intuitive to me, I would like to correct that. I think that was the wrong term for, and I don't teach the word intuitive, because when someone comes to you, if you're going to be working in the health field, someone's going to come to you with an eating disorder or disordered eating, and they're going to intuit that into their intuitive eating, okay? I was intuiting that I needed to intermittent fast, and that's what felt good. And I removed gluten and dairy and soy, and I removed any additives, and that's so intuitive to me. So try not to use intuitive. Biological rhythm of hunger is the word. It's biological. It's like saying, I intuitively urinate every day. How's that sound? Right. Right. Like I intuitively took a shit. I intuited when my bowels moved. You don't. It's a biological sense. This is a sense. This is not an emotion. That's the part that I say stop with intuitive. That's too emotional and there's way too much bias and mental health problems that can infiltrate into what's intuitive. So we're calling it biological rhythm of hunger. Okay, hunger, very different than desire or cravings. So the hunger scale typically is a 1 to 10 scale. Now I try to think of it in two ways. Hunger is from 0 to 5. Fullness is from 5 to 10. Hunger, fullness. Now it's, and I'm gonna make it even, we're gonna like focus in a little bit more than that. Okay, so you need to pay attention because you're gonna be using this scale to find out, observe when you actually get hungry. So where on this is, should you eat? Should you wait till you're a 5? Well, no, because that's neutral actually. So we're gonna look at it, reframe it. So the hunger scale is on this side, the fullness scale is on this side. Okay, so I will post a PDF that has all these descriptions for you and the numbers. Okay, so think of it as an upside down U curve, just like this. This is the Goldilocks zone, because right here there is no hunger. This side is fullness. And this side is hunger. Okay, so we'll start with 1. So, and we'll finish with 10. Actually, let's start at the top. We're gonna start up here. So this is a 5. Okay, so 5 is neutral. Neutral. So I'm right now, I'm not hungry at all. I have no symptoms. I might be a 4.75, which is like, I could eat. I could, but I'm not that hungry. Neutral, okay? Now I will tell you this. I'm gonna keep on going, I'll come back to that, so 5 is neutral. Okay, 6. Six is. Can't remember if it's sated. My God, literally have written 4 books on this topic. And I cannot remember, that's how long it's been since I've. Okay, let's go this way. 4. 3. And 2. 4 is, I'm hungry. But I am patient. It's not an emergency, so it's not emergent, but you're hungry. So I would say a 4 is like, you're going out with your friends. You totally are patient to go to a restaurant and wait to be seated. That's a 4. You are patient and you're totally cool with a 30-minute wait. Okay. A 3, not so much. You are now that time, that part of the conscious effect, the brain effect of hunger is that there's time constraint involved. You will feel like, nope, I'm going to fast food. No, I can't do it. So this is, I will wait, I'm patient hunger. 3 is, yeah, no, I need something now, I'm irritable. At least if we go to a restaurant, I'm gonna need an appetizer. Can I get something now? So it feels a little bit more emergent at a 3. Very big difference right here. In fact, you could say that this scale, you know, it's kind of flattened here, and then it goes like this, like that, like it decelerates real fast. That makes sense? This can happen. The time it takes to go between a 4 and a 5, of course, depends on how much body fat you have, how much expenditure you have, but it can take 2 hours to go from a 5 to a 4. Or I don't know, I mean, you need to listen to your body. But the time it takes to go from a 4 to a 3 can be 20 to 30 minutes. Very fast, because it's at the point at which you feel hungry at a 4, what is your body starting to tap into for fuel? Leptin goes down. The body has to make up the difference. Your body's using blood sugar. Your brain gets a little pissed off. And that's why this is like, yeah, no, you're not touching my glucose. The brain registers a drop in glucose. There's a drop in brain leptin, and this happens pretty fast. So once you're at 4, your body is starting to use the glucose in the blood that was really regulated for the brain. Too much relative to your expenditure. Does that make sense? So if you're at a 4 and you're patient, just know, hey, let's prepare. I need to be ready. What do I have? Can I tide myself over? Like if I'm in a 2-hour class, I didn't bring food, what can I go out and get a snack just to tide me over? Right? So I would say ideally you don't get to a 3. Because then you become a little bit more, you become less picky about what you're eating. Because the brain and the palate, your brain, that hedonic pleasure center of the brain is directly tied to your tongue in your mouth because of food and the how it works around appetite or like craving what sounds good to you has a lot to do with your brain's memory of texture, pleasure, right? So when you get to a 3, your brain says, screw that, crackers, right? It doesn't matter if it tastes good or not. I'm agitated. Hunger is an agitation. It's a form of pain, right? So as you get more and more in pain, you become less discriminative about what you're eating. And you don't care so much about the pleasure. You're more concerned about getting rid of the agitation and pain. So ideally, if you have the ability, you would eat it at 3.5. You know, there's clearly a plus or minus on that, but I like to say 3.5 because at least at that point, you're still looking at a menu and going, ooh, what sounds good? And what sounds good to you is chances are coming from that hedonic area of the brain. You need to listen to that. Pleasure is super important in digestion. So this allows you the patience for pleasure, which means you're going to have an increase in digestion. Have we talked about that yet? Oh my gosh, this is over 100 years old science. This is still well known. I don't know why people don't talk about it. If your food doesn't taste good, it doesn't digest. Like good food. It does not digest if it does not taste good. Like tasting good food does. There's so much research on this. That happened with Pavlov, like 1800s, they knew this. Everybody should know this. So if you're eating non-pleasurable food, you're eating super fast, it's not gonna digest the same as pleasurable food. With the patience, it will digest better, creating more saliva, but better peristalsis, which means your whole gut is working better when you have higher pleasure in your food. So a 3.5 is ideal if you can manage that. So let's say you start eating. Let's keep on going. 2 is my head hurts. Energy is reducing. This is the point at which you're probably feeling like, I don't know, I'm just tired. I don't want to eat. I'm done. That's what that feels like. It's like the lights are dimming, your head hurts, you're beyond agitation at this point, and you could just, you probably don't even need to eat at this point because you're beyond that. So this is the point at which you are now in starvation. So the thyroid is suppressed and your body's using alternative, i.e. protein, fuel sources to make up the difference plus the glycogen, right? So this is ideal. 3.5. Any questions about the hunger side? So once you start eating, this 5 point is really hard to recognize because your brain is stimulated, right? So I don't recommend stopping at a 5. I think that's not very nice, actually. Don't stop at 5. You want to make sure that you are satiated. Yes, satiated. I knew it. You're satiated. Okay. Oh, actually, it's content. I'm sorry. This is content. 7 is satiated. Satiated. Okay, there's the difference between the 6 and the 7. Okay. Don't stop at a 5 unless you are in a famine and you are trying to minimize the amount you can eat in a very long period of time. If I was living in the wilderness and I had to preserve my food, I probably would stay around right here. Because this is where you're getting optimal thyroid to be able to hunt. Okay. So we don't need to do that. You can probably go somewhere around the 6. So there is something called lag time. Do you guys know what lag is? Someone describe lag to the class.
Like a delay.
It is a delay, yeah. Like you can push stop, but it's gonna go stop. There is lag to how hunger responds. So if you stop at a 5, it'll probably end up at a 5.25. If you stop at a 6, it'll probably stop at around 7. Right? So I like to say, make sure you cross the center point. Because what I've noticed is like, this is a ball. We're rolling a ball up a hill. If you stop at a 5, it's going to go right back down pretty fast. So one way to think of this is if you were asked by a friend to go move, help them move furniture, a lot of it. It's like crisis, they need your help. You're hungry. How much would you eat before you go move a ton of furniture? You're going to eat until you're at 8, which is full. Okay, so are you going to eat until you're full? Which means you're having mechanical pain because of the food in the stomach. Right? It's mechanical. When you say I'm full, you are not feeling a lack of hunger. You're feeling too much food in the gut. Okay, so I do not recommend this. Okay, would you eat until you're full if you're about to go move furniture? How about run 5 miles? No, you're probably going to want to stop in the zone. I've had enough. I'm confident that I'm not gonna be hungry in the next couple of hours. Make sense? And this, you're gonna have to go lay down. 9 is pain. This is mechanical stress. 9 is pain. I have to unbutton my shirt and or my pants. I gotta go lay down. And then 10 is I'm nauseous, like you are literally, you just made yourself so sick. And it's dangerous. This is danger. Danger, toxic, sick. We've all done it. Halloween, when you were like 10 years old. How many of you guys ate so much candy, you literally puked sick? Is it just me in here that's done that? Am I that crazy? Right? This isn't bulimia puking. I'm talking like you are toxic. So the ideal zone here would be in 3.5 to 6.5. Manage that. So we'll talk more about this on Wednesday. So good job, you got through that big lecture.